It says sketch and label on the same sort of axes the graphs of the y equals the modulus of x and y equals the modulus of 2x minus 4. Okay, so this one is a not too bad. So let's have a go and see how we get on. So let's get axes going. Immediately, the modulus of x, we know what that looks like. That's just y equals x with a flip. So remember, to draw modulus, you draw the original graph y equals x like that. And then you just reflect the part underneath the x-axis in the x-axis. So I'm going to rub this part out. I need the point eraser for that. So I'm going to rub that part out. And then I'm literally just going to put a V like that. And this is going to be the modulus of x. So that is part A done. We need to draw the graph of y equals the modulus of 2x minus 4. So again, always draw the original graph. So y equals 2x minus 4. Let's get both intercepts. The y-intercept is at -4, so let's just say it's like around there. The x-intercept is when y equals 0. So 2x minus 4 is equal to 0. 2x is equal to 4. X is equal to 2. So it's gonna go like that. So let's just say it's like that. Okay. And the graph will look like this, basically. Okay. And one thing that's super important as well is that the gradients are different, aren't they? Right. So because it's a sketch, right? You all still want to just make sure it is accurate. So when I draw the graph of y equals 2x minus 4, I'm making sure that that gradient, right, is a bit steeper than that one. That's super important. I'll never forget why. I remember one time when I was your age, I was doing a past paper and I was doing this type of question. I didn't draw, I didn't draw the gradient steeper or flatter than one of the graphs, and I kind of drew it parallel. And because of that, I missed the solution. Yeah. So because of that, I always just remember to do that. Yeah. I remember my good friend Marvelous, he actually told me, he explained it to me. The gradients are different. So the graphs are going to be steeper than one another, right? So it's super, super important that you always just account for the gradients. Just draw it a little bit steeper. Okay. So this is y equals 2x minus 4. But remember, we don't want that. We want the modulus, don't we? So again, let's rub out the bottom part and then just reflect it. So I need is it the point? Yeah, I need the point one. So that's going to go like that. That's going to go like that there. And then I'm just going to flip that up. So it's like that basically, isn't it? Whoops, I need a pen, not a highlighter. Sorry. So it's going to be like, pretty much like that. Like that. And then that was a 2. That was a 2 over there. That was a 4, like that. And this is the graph of y equals the modulus. 1 second. Y equals the modulus of 2x minus 4, like that. Everybody happy with these two graphs? Did you guys get this correct in your workings out? Does it look like this? Yeah, good stuff. Brilliant. Okay, now part B, it says solve the modulus of x is equal to the modulus of 2x minus 4. So it's really good and important to always sketch the graph because you can see quite clearly there's only two solutions. And because you're sketching it, you are able to determine what those solutions are for. So for example, that one, well, for this one here, what graph are we drawing? Well, this part of the graph is going down. This is going to be the negative version of modulus of x or modulus of 2x minus 4. And it's intersecting with that positive branch, right? So essentially, there are only two solutions, and both solutions are just always intersecting with the positive graph of y equals x, isn't it? So the first solution, which I'm going to call solution one, where should I do it? I'll do part B here. Um, BI, solution one. The first equation is going to be when y or when x, right? Remember, this yellow graph is y equals x, isn't it? This is y equals positive x. It's going to intersect with this part here. That downwards green graph is the graph of negative 2x minus 4. And then the second one, right? Which is this one here, right? That yellow one, which is y equals positive x, this is intersecting with the positive version of y equals 2x minus 4, right? So it's going to be like that. These are going to be the two solutions that I'm solving, or the two equations that I'm solving. Is everybody happy with that? Does that make sense? Yeah. So now it's just a matter of solving these linear equations. So that one, let me solve that. If I'm gonna time, I always expand. I don't know why. It's easy to times by -1, but I just expand. Minus 2x plus 4, like that. Move that over. That means that 3x is equal to 4. That means that x is equal to 4/3. That's one solution, right? Which is going to be that one. That's going to be 4/3. 4/3 is bigger, is smaller than 2 because 2 is 6 divided by 3. So you know that that's definitely 4/3. And then the other solution is that one, which is bigger than 2. So always just have your pivot, your turning point as a point of reference. X equals 2. You've got one solution to the left of that. The other solution should be to the right of that. So let's do that. That's just x is equal to 2x minus 4. That is, move that there, move that there. That's going to be positive 4 is equal to 2x minus x, which is just x. So x is just equal to 4. And that goes there. And that one is like that. So your two answers for your solutions are x equals 4/3 and x is equal to 4. Does that make sense? I think a couple of people got that correct. I think somebody didn't, from what I saw. Can't remember, but I think I remember somebody not getting this, or somebody getting maybe one of them. If you didn't get it, or you got it partially. Does that make sense? Now we happy with that? Where is my view responses there? And then let me get up. Oh, it's there. Okay. Yeah, I can see somebody just got 4/3 and they forgot x equals 4. Yeah. Everybody happy with that? That the two solutions are 4/3 and 4? Yeah. Okay. You guys can hear me, right? I'm not frozen or anything, am I? See, take a note of the positive and negative sides. Help me make corrections. Yeah, yeah. Always just yeah, the positive and the negative thing, stuff like I always do when I'm doing modulus questions because they can definitely trip you up. Yeah. Okay. So, what are we doing now? Part double I. It says, hence or otherwise, solve the inequality. The modulus of x is greater than the modulus of 2x minus 4. Well, we've got everything we need. We've got the two graphs. Greater than, that just means when I do these questions, remember, I used to love these questions when I was your age. Literally, all this is saying is, when is y equals the modulus of x above y equals the modulus of 2x minus 4. This is literally, there's no maths needed in this. It's just a looking problem. You're just looking at the picture, right? When is that v, when is this v here above that v? Let me get rid of all of these highlights. It looks a bit ugly. Let me get rid of that. Get rid of that. Oops, I got rid of a branch. My bad. I'm trying to get rid of that highlighter. Okay. Let me get rid of these. So yeah, that's all I need. Now, when is this v above that v? Well, if you think about it, right? The pivot for the what modulus of 2x plus 4 is down here, right? You can see quite clearly that if I put a man there, right, that man is standing on top of the y equals the modulus of x. And in that same region, the modulus of 2x minus 4 is underneath, isn't it? Remember, the red points are where they are the same, they're equal, right? In between, that man is on top of the modulus of x graph, and the modulus of 2x minus 4 is underneath, right? The moment I go to the right of the moment I go to the right of this point here, the man is now up here, isn't it? Which is on top of the modulus of 2x minus 4. So can you guys see? Just let me know if that makes sense, yeah? This region here, this area here, the man is on top of the modulus of x graph, right? So therefore, this is where the graph is above. The modulus of x is above the modulus of 2x minus 4. Yeah? Guys happy with that? Let's see. Yeah? So therefore, right, what is the value of x? What are the values of x for when this stick man is above? Well, it's between 4/3 and 4, isn't it? Right? It's between 4/3 and 4. So the answer is literally just going to be, do it here. Oh yeah, I'll do it here. It's just going to be when x is between 4/3 and 4. Because remember, when they're equal, x is 4/3, or when x equals 4. The moment I go in any direction, we have one of the two being above the other, right? When we're in between 4/3 and 4, the modulus graph, let me highlight it so it's super clear. This modulus graph right here is above, isn't it? Yeah, perfect. So that is it for that one. So that's done.